Hey everyone, we're going to take the last section 1.9 about percentiles and z-scores. So the first question here, let's just talk here. They've got a set of stat quiz scores here in the percent form. I believe there's 20 of them. The mean is 80 and the standard deviation is 10. So our first question here, Biff scored a 60 on the quiz. What percentage of the scores are less than 60? Well, here is 60 right there, okay? Now I'm looking at less than 60. There are 3 scores that are less than 60. Out of 20 total scores, that's 0.15, but they're looking for a percentage, so that's 15%. Right there, 15% of the scores are less than 60. Part B, Marty scored a 90 on the quiz. What percentage of the scores are less than 90? Well, here's 90 all the way up here, and I noticed there's about 18 scores that are less than 90. If you want to count 89 all the way to 55, there's 18 scores less than 90, 18 out of 20 total scores, and that's 0.9. But again, they're asking for a percentage, 90%. Okay, these two parts, A and B, that's to find percentiles. Okay, so if they're asking for a specific percentile, that's how you find it. Next, how far away from the mean is Biff's score of 60 and in what direction? Well, they give you the mean back here. Remember, the mean is 80. So how far is 60 away from 80? Well, that's 20 below. Hopefully that's pretty easy to figure out. How many standard deviations is 60 away from the mean? Well, if I take my 20 below, right, and I divide it by my standard deviation, they give us is 10. That is 2 standard deviations away from the mean. Number 3. How far away from the mean is Marty's score of 90 and in what direction? Remember, the mean is 80. So if Marty's score is 90, that's 10 above. 10 above. How many standard deviations is 90 away from the mean? Again, just take your 10 above and divide it by 10 standard deviations, or the 10 standard deviation, and you get 1 standard deviation. Okay, number 4, how far away from the mean is 87 and in what direction? Hopefully that's pretty simple for you. That's 7 above. How many standard deviations is 87 away from the mean? Well, again, take your 7, divide it by 10, and that's 0.7 standard deviations. Okay, one thing they don't really talk to you about, but I'm going to introduce it to you, is this thing called a z-score. Okay, the z-score is the number of standard deviations that a piece of data is away from the mean. Okay, so it's the number of standard deviations away from the mean. So to figure out the z-score, okay, and I'm going to show you how to calculate it. All you do is take your data value, x, and you subtract your mean, which is x bar, and you're going to divide it by your standard deviation, s. Okay, and I'm going to show you how to do it here in a couple of these. So like for number 2, our value to find our z-score, you take your value, which was 60, subtract your mean, 80, and divide by your standard deviation, 10. So 60 minus 80, which is negative 20, divided by my standard deviation, 10, will give me negative 2. So that would be my z-score. And that makes sense because I'm 2 standard deviations below. Number 3, if we have a score of 90, so I just take my 90, subtract my mean of 80, divided by my standard deviation, 10. So 90 minus 80, which is 10, divided by my 10. That's going to give me a positive 1 z-score here. Okay, and that makes sense because I'm 1 standard deviation above. And then same thing here. If I do 87 minus 80 divided by 10, that's 7 divided by 10, which will give me that 0.7, that positive 0.7 standard deviations. And we'll be doing these z-scores here for the next semester for probably till the end of stats. So you'll get used to them. Just some important ideas from the text. So the first thing is percentile, which was the first two questions that we talked about, or the first question, part A and B, which is the percent of values that are less than the data value. Okay, so notice that from number 1A and B, so we were always looking are less, okay? So that's percentile, less. Some percentiles, Q1, that's 25%. The median is 50%. And then Q3 is 75%. Hopefully that makes sense. If it doesn't, just let me know and we can talk about it or figure it out. Another important idea is the percentile graph. It kind of looks like what we see below here. This graph right here is a percentile graph. So that's another important part of the text. And then the last thing is the z-score. And then the z, to calculate that, you take your value minus your mean divided by your standard deviation. If you want to interpret your z-score, okay, so if they ask to interpret it, is the number of standard deviations above or below the mean. Okay, if it's positive, it's above. If it's negative, it's a below. Okay, so that's if you want to, if you're trying to interpret. Okay, if they ask you to interpret the mean, or I'm sorry, the z-score, you would say, you know, whatever it is 3 standard deviations above or below the mean. So if it's a -3, you would say the z-score is 3 standard deviations below the mean of whatever it is, the test scores or whatever. Okay, we're going to do one last application problem here. The cumulative relative frequency and the numerical summaries below describe the distribution of household incomes in the 50 states in a recent year. Okay, we're going to just call this the percentile here. Okay, they give us the number of data is 50. The mean is 51,742.44, and the standard deviation is 8,210.642. I got that from that graph over here, or that table. Okay, at what percentile is North Dakota with a household income of $55,000? Okay, so at 55, $766. So I'm going to go a little bit above here. So if I kind of go straight up and then across, I would, say it's probably around the 70th percentile, approximately. Estimate and interpret the first quartile of the distribution. So the first quartile, I would say would be, remember, the first quartile, that's 25th percentile, okay? So on the y-axis, if I'm going at 25%, somewhere right here, I would say Q1, right, is the 25th percentile. And that's about $45,000 is what I would say. Okay? Interpret, I would say all income of $45,000 is higher, right, than 25% of all household incomes. Okay? Basically, all incomes of $45,000 is higher than 25% of all household incomes, right? There's 25% less than $45,000. Basically is what that means. Okay? Number 3, find and interpret the standardized score, the Z-score for New Jersey with a household income of $66,692. So again, the Z-score, I'm going to take that value, 692, subtract the mean of 51,742.44 divided by the standard deviation, 8,210.642. I get about 1.82. All right, so interpret, I would say the New Jersey income of $66,692 is 1.82 standard deviations above the mean income. All right, so that's all I've got. Let me know if you have any questions.